Okay. Get your problem set in.
Well, I can contact IBM.
Okay.
Just
Okay. So far we've been working with only competitive models, and that assumes that everyone takes prices as given. That means that any firm believes that if it charged a price that was even a little bit above the market price, it wouldn't get any demand, or that if it increased its production, that would not cause the price to fall in any way. And those assumptions, as you can imagine, are never literally satisfied and are a pretty bad approximation in the details of thinking about many markets. So today we're going to begin studying, and sort of for the rest of the course we'll study, cases when firms have an incentive to change their actions so as to change prices. So we'll begin by asking what a monopoly is and when we should use a monopoly model to study a particular market. We'll then talk about the incentive that firms have to reduce their quantities and go through the notion of marginal revenue with mathematical and graphical examples. We'll learn the Lerner elasticity pricing rule, which is a basic way to think about the trade-offs between charging a higher price and selling more, and some alternative metrics of the notion of market power. And then we'll talk about some data that allows us to analyze firms' optimal pricing. We'll then talk about deadweight loss from monopoly and incidence and pass-through under competition and monopoly. And that'll finish up the lecture. Okay, so the monopoly model sounds, because it's monopoly, like there's just one company in the whole universe, right? But the basic mechanisms that we'll learn in the monopoly model are going to apply to any situation when a firm doesn't act as a price taker. Anytime a firm can affect the price at which its goods are sold. And really, the monopoly model applies more or less depending on whether the size of the distortion that's created by the monopoly. So question is, when does it make sense to apply a monopoly model versus an oligopoly model? Is How Jan here? Yeah, How? Oh, Andy. Damn it.
Sorry.
I keep forgetting this is your real name.
Yeah.
Sorry. Andy, what affects, when do you think monopoly is the right sort of model to use versus oligopoly? When would you try to apply one or the other?
So I guess monopoly is for when we're trying to focus in on the effects on one firm in the market, and then when we want to consider how possible welfare effects when there's multiple parties or companies involved, we might use oligopoly.
Yeah, that's right. It sort of has to do with what the focus of the analysis is, rather than like whether there is one or multiple firms. So put it in the P-set 3 folder. And you can pick up your P-sets 1 and 2, yes, after class. I know, because he already took a bunch of them. These are your old P-sets. I guess none of them have been turned back yet, but here they are. Monopoly focuses sort of directly on the effects of interventions on an individual firm, and therefore ignores the effects that some intervention on the firm could have through the changes in behavior of other firms. So if I come in and I put in a tax, a monopoly model is only going to think about how that causes that firm to raise its price and therefore the change in demand. It's not going to think about the fact that if I put a tax on, that might also affect the other firms in the industry that are competing with that firm. So it's not really that a monopoly model is about a market where there's just a monopoly. It's really about a model where you're ignoring any effects that happen through firms other than the ones that you're focused on. Monopoly also affects welfare, ignores welfare effects that come through other firms. And in particular, any pecuniary or non-pecuniary externalities on firms other than the one that we're focused on are going to be ignored in a monopoly model. So it can't be used to think about cross-firm externalities. It also obviously can't be used to think about changes in the structure of the industry. So if we are changing the degree of competition, a monopoly model is going to be useless to think about that, right? So we're going to focus on the incentives of a single firm, holding fixed what's going on with other firms, but that's going to be an input to thinking about what goes on with other firms, because every firm is sort of a residual monopolist on the demand curve that's defined given what other is going on, in some sense, with other firms. Okay, so the basic idea of monopoly is that firms want to reduce their quantity in order to raise the price that they get. And the reason is that in order to sell more goods, they have to not just lower the price on the marginal goods that they're selling, but also on the inframarginal goods, the goods that they would sell even if they didn't lower their price. And on Thursday, we're going to talk, actually not on Thursday, sorry, this lecture has been moved to later in the course. So anyway, at some point we're going to talk about the possibility that they could charge different prices on different units they sell. That's called price discrimination. So monopoly is going to want to reduce quantities below the point. Agnes, you can drop your problem set in that folder. And your old problem sets are here. Okay. So monopoly will tend to want to reduce their quantity below the point where price is equal to marginal cost, because that will allow them to earn some extra profits by increasing the price. Now, monopolies trying to reduce quantity is something we see all over the place in the real world. Wesley, what are some examples you can think of where some firm that controls the market a lot tries to reduce the quantity below what it would otherwise be?
So, I guess digital software.
Mm-hmm. That's a great example.
The MP3s. So
Yeah. Yeah,
a
so
lot of digital industries.
yeah, any sort of freely available digital product, a firm that has IP over that is going to try to restrict the consumption of that good, right? Occupational licensure, as we talked about in the first class, they tried to restrict the supply of doctors. Labor unions often oppose immigration or have closed shops that don't allow people to freely participate. Farm cooperatives try to prevent overproduction, quote unquote. You often hear farmers talking about, oh, there was a glut of production in the industry this year. That's because they want to reduce production in order to try to raise prices. Drug cartels are constantly killing other people who try to produce the same drug that they produce, right, in order to try to raise the price. So, in fact, when they killed Pablo Escobar, I don't know if you guys have heard of Pablo Escobar, but he was like the head of the Medellin cartel, which is the most powerful drug cartel in Colombia. When they killed Pablo Escobar, actually the price of cocaine went down. And the reason, in other words, there was more cocaine available. And you would think, well, you killed the guy who runs the cartel, wouldn't that? But no, of course, it actually increases the amount of cocaine because he's no longer around to kill all the other people who are producing cocaine, right? So he was actually a very effective drug enforcement agency. And you kill him off, and then there's actually going to be more cocaine, right? So drug companies invest massive amounts of money in reducing supply of goods by preventing reimportation of their drugs from other countries, by having strictly delineated territories in which drugs can and cannot be sold, etc. Digital materials, as Wesley was saying, are a great example of this. Okay, so to represent this, we're going to write that the firm's revenue function, R of Q, is P of Q times Q. Under perfect competition, price would be just set equal to marginal cost, right? But now a firm's going to want to set their marginal revenue equal to their marginal cost. Now, if they took the price as given, the derivative of P, if P is fixed, times Q with respect to Q is just P. So you would set price equal to marginal cost. But once you take into account the fact that you have on price, that's not the case. Okay, so by the product rule, Wesley, what is the marginal revenue? What's the derivative of the revenue with respect to quantity?
So it'd be P of Q and then plus P prime Q times.
Exactly. So we get this equation, which is that we have the standard thing, which is just price, right? Which would be set equal to marginal cost if there wasn't this extra term. But now you also take into account the effect that you have on the price when you change your quantity, which is the change in price multiplied by however many inframarginal units you're selling, Q. That term is called the market power term or the Cournot distortion. Okay. It's also sometimes called the marginal, the negative of that is called the marginal surplus, because when quantity increases, consumer surplus increases, and revenue increases, the two of those things together sum to be the demand curve. So the difference between price and marginal revenue, which is the negative of this term, is sometimes called marginal surplus. Okay. So there's two terms here, right? There's the standard term in a competitive market, and then there's a second term, which is always negative because price always falls when quantity increases, right? And it gives you an incentive to reduce your quantity. And the distortion is proportional to the quantity you're selling and the impact that a change in your quantity has on prices, right? Which are both measures of sort of how important your firm is in the scheme of things. And we'll talk more about that later. Okay, so let's derive this for some simple examples for some of the most common curves. So first, let's consider a concave demand curve. 1 minus Q squared is the price, right? Or if you wanted to write it the other way, 1 minus the square root of 1 minus the price would be the quantity. So is Lewis here? Lewis is not here. No. Gets his problem set in. Anyone else want to try to derive the marginal revenue for this curve? Remind me of your name? Ryan. Oh, no, sorry, no. You, yeah. Sang, why don't you go ahead?
So the revenue is P times Q, so Q minus Q cubic.
Yeah?
So if you take the derivative of revenue, then it's 1 minus.
Yep, you've almost got it. 1 minus?
1 minus 3Q squared.
Exactly. Right? So notice that this is going to diverge from this at an increasing rate because the difference between them is like negative Q, 2Q squared. So that's going to get bigger as Q gets bigger. So these start at the same point, and then they're going to diverge increasingly quickly. How about linear demand, Matt Solomon?
Yeah, so you could do the same thing, and you have revenue equals Q minus Q squared. So the derivative of that is 1 minus 2Q.
Okay, that's exactly right. So can I call you King Solomon?
Sure.
Yeah, so we bring in as many biblical things as we can. So these diverge from each other, but they diverge at a constant rate because this is 1 minus Q, this is 1 minus 2Q. This is going to be twice as steep as this, right? And so they'll just diverge from each other at some constant rate. Okay. And again, these start at the same point just like they did here. Okay. How about for an exponential curve? Israel, you got to derive this.
So we take P of Q, which is 1 minus log of Q, plus the derivative, which would be negative 1 over Q times Q, which would just be negative 1.
Exactly.
So we get
That's a
1
nice way to
minus
derive
1,
it.
so it just becomes negative log of Q.
Exactly. So this differs from this by a constant amount.